How's it going? We're talking about how we put old video games on new hardware. So this can be done through software emulation, hardware emulation, or through like backwards compatibility. So with software emulation, you take a program and you say, you are this other computer, and you pretend to be that, and then you just run the game kind of as it. Generally, this requires a lot more computational power, but it's pretty easy to move your games between devices because you just need to adjust the emulator rather than the games themselves necessarily. So with emulation, you can do cool things such as adding in save states or running at higher resolution. With hardware emulation, you use an FPGA chip or a field programmable gate array to rebuild that chip into the chips that you want from whatever computer you are pretending to be. Hey, for sake of clarity, FPGA or hardware emulation is basically a specialty built machine. Upside, you can, in theory, assuming the FPGA is capable, make just about any chip in the world. Downside, you really need to know your stuff. You need to know how this thing works on a software and on an electrical level. Other downside is you don't really get access to the enhancements that emulation through software means would provide. But you are gonna be super accurate. In terms of like computing speed, hardware emulation is super fast. But the reason why this isn't really like a problem for like old enough systems is that new computers are just so much better than old ones that you have the sheer like brute force just to do everything super fast, rather than it necessarily being inherently fast on terms of like a cycle scale. That's that. And then there's backwards compatibility, where you just include hardware from the system you're pretending to be inside of it. The Game Boy Advance has its own CPU that it uses, and then it has a Game Boy Color CPU, because that was made to be super similar to the original Game Boy, and basically it's just a Game Boy 1, but like twice as fast. So when you play older Game Boy games on a Game Boy Advance, it just says, all right, we're going to Game Boy Color mode, and then it doesn't touch the Game Boy Advance like new hardware. And then when you play Game Boy Advance games, you just have the Game Boy Advance CPU. You don't get access to both. It's kind of a trade-off you're making. And then we have recompiling the game. So what's going on here is basically you're taking the set of instructions that were used to create the game into a runnable app on the original device, and you are making it work with the new thing. So the upside with source code is that you have a lot more flexibility, so you don't need nearly as much computational power to move between device to device. In fact, you might even need less. I believe the 3DS sits about between the N64 and the GameCube in terms of power. It can't run a Nintendo 64 emulator as far as I'm aware. But with source code, you can do things such as port Super Mario 64 to the 3DS, because it's just running native. Pretty cool. So that's what you do with source code. Decompiling is basically taking the completed product and reverse engineering your source code out of that. For the remainder of this segment, I'm talking about a recompilation tool rather than taking the source code and then compiling it again. And now, one of the newer things, which is what spurred this video, is recompilation. There was recently released a tool that recompiles Nintendo 64 games to work on PC and Linux. So basically what it does is it takes the ROM, it looks at it, and it goes, all right, here are all the Nintendo 64 specific things. I'm going to go, when you see this, actually do this, which is just the equivalent Windows or PC thing to do. So this is going to sound similar in theory to what an emulator does. What happens is you are freeing up a layer of abstraction and freeing up like a layer of having to do a bunch of brute force computing. So what the recompiler does is it looks at N64 instructions and say, this is what you need to do on this machine. And that's done ahead of time. So it just kind of runs natively. Upside, you don't need nearly as much computational power to get it to work. The downside is recompiling doesn't give you source code. So you still would prefer to have the source code, but if you know enough about the game's ROM, can more or less convert just about any N64 game into a native PC port, which is really cool, because that means if they want to remake a Nintendo 64 game, but they have a low budget, they can still, like, get something out. But that's the idea. Anyways, real quick, emulation is not illegal. The problem that most people have with emulation is, in fact, the problem of piracy, which is not an emulator's job to, like, really worry about. Basically, the emulator just plays the games. It's like if you stole gasoline to run your car, it's not the car's fault that you stole gas. Anyways, there's court cases on it. Look into the Sony v. Bleem and Connectix cases. They're legal. You can sell emulators if you want. Most people don't, but you can. Things such as the Wii Virtual Console and the Nintendo Switch Online apps are just emulators. So yeah. Anyways, maybe I'll say something where I cry about Green Hill Zone.